Chemical equations. A chemical equation is a symbolic representation of a chemical change. A chemical equation shall be made more informative by indicating the physical state, heat changes, gas evolved, and precipitation formed. Such characteristics of reactants and products. Exothermic reactions and endothermic reactions. There are two types of reactions. Let us see exothermic reactions. A reaction in which heat energy is liberated by the products is called exothermic reactions. Example, CaO plus H2O gives rise to CaOH plus heat, calcium hydroxide it is called. Okay, so endothermic reaction, a reaction in which heat energy is absorbed by the reactants is endothermic reaction. N2 plus O2 gives rise to 2NO, nitrogen monoxide, okay, plus heat. So, balanced equation can give the following information. About the reactants and products, relative masses of reactants and products, molar ratio of reactants and products, volume of the gas evolved, number of molecules and atoms of different substances formed from equation. A chemical equation should always be balanced according to the law of conservation of mass. Note, the symbols of elements and formulae of compounds should not be changed, but only their coefficients should be after by balancing the equation. So they will be only alter, they will be only changing. The coefficient of should be least possible whole number. If you cancel it, you should maximum smallest number should be there. Okay, steps, let us see. For example, NH3 plus Cl2 plus gives rise to N2 plus NH4Cl, that is called ammonium chloride. N2 means nitrogen gas. So write the unbalanced equation. Compare the number of atoms of each element on both sides. Then let us proceed for the further steps. Okay, the further steps are like this. Step number 3 will be by comparing the number of atoms on both sides are not equal, so the given equation is unbalanced, we can decide. Okay, to balance the number of atoms on both sides, lowest possibles of whole numbers are to be taken. 8NH3 plus 3Cl2 gives rise to N2 plus 6NH4Cl. It will be happened. If we check on both sides, now atoms in LHS, atoms in RHS are same. Nitrogen 8 8, hydrogen 24 24, and chlorine 6 6 atoms on both sides, LHS and as well as RHS. So like this, by seeing a chemical equation, first of all we have to check the number of atoms on both sides. If both sides are equal, there is no need of balancing. If both sides are not equal, then we should proceed for the process of balancing the chemical equation. Okay, now, so before balancing a chemical equation is called a skeleton equation. What equation? It is a skeleton equation. Before balancing of a chemical equation, it is called skeleton equation. So we have to balance the skeleton equation which was given in a particular exam or whatever it may be. So by checking the both sides atoms, we can balance the equation. Point to be noted, your honor, that is what, only number of moles should be altered. Okay, not number of molecules, only number of moles should be changed during balancing. So why should we not balance a chemical equation? Why should we balance a chemical equation? So let us see. Chemical reactions always obey the law of conservation of mass. So the total number of atoms on each element in the reactants must be equal to the total number of atoms of each element in the product. So we should have to balance the number of atoms on either sides of the equation. So element, number of atoms and number of atoms in RHS. So you can see LHS side 3, 8, 2 are there, carbon, hydrogen, oxygen. This side in RHS 1, 2, 3 are there. So we have to balance this equation. So by comparing the number of atoms in each side of the equation are not balanced, we can observe. So above equation is to be balanced by taking the coefficients as in possible smallest ratio. That means coefficient numbers only we have to take to change or to balance the chemical equation, right? So can you try this equation for balancing? You can try it your own. So it will be finished like this. C3H8 5O2 plus CO2 plus 4H2O. You can see both sides LHS and RHS number of atoms are tallied. Okay, so like this you can balance the equation. Now here is a small problem. That is what how much lime can be obtained by the calcinations of 300 grams of limestone. Limestone means what? A calcium carbonate. If calcium carbonate is heated, calcium oxide plus carbon dioxide is released. So you can see calcium carbonate molecular weight is 100 grams. Calcium oxide's molecular weight is 40 plus 16. That is equal to 56 grams. So 300 grams of calcium carbonate gives 56 grams of calcium oxide, but 300 grams of calcium carbonate gives x grams of calcium oxide. So if you take this problem and if you calculate x grams is equal to finally 300 into 56 by